Hello. In this video, I will discuss the solution to question 2 from homework number 11. So question 2 says, it is suggested that the following functions of v, a, f v is equal to e to the power mod of minus mod v, b, f v is equal to sine square v upon v square, and c, f v is equal to 1 for mod of b less than equal to alpha and 0 for mod of v greater than alpha. And then we have been given this graph for part C. So these may represent an autocorrelation function for a WSS process, a WSS stochastic process, by setting v is equal to tau, or a spectral density function by setting v is equal to omega, or both. So we have to find out which functions fv may represent either or both, and we have to explain our answers. Okay, so moving on to the solution. So if r tau is an autocorrelation function of a real wide sense stationary stochastic process xt, so if this is given, then r of 0 has to be greater than equal to r of tau, and also it is even. So if these conditions are met and the Fourier transform is also non-negative, and then its Fourier transform is also non-negative, and then S of omega is non-negative if it is a power spectrum of a WSS process xt. So now to solve these three sub-questions. So f of v is equal to e to the power minus mod of v, and e to the power minus mod of v, it is an even function. Then e to the power minus mod of v, it is less than equal to e to the power minus mod of 0. So then we also have this is as 2 alpha upon alpha square plus omega square is equal to this, so which is non-negative. Therefore, it may represent an autocorrelation function, and e to the power minus omega is also greater than equal to 0, so it may also represent a power spectrum. So moving on to part B, where f of v is sine square v upon v square. So sine square tau upon tau square, so this is even. Then sine square tau upon tau square, it is less than equal to limit tau tends to 0, sine square tau upon tau square, so this is equal to 1. And this is the graph that is for this, that is sine square tau upon tau square. So this is non-negative. So it may represent an autocorrelation function. Again, now if we put omega in this function, then sine square omega upon omega square, it is greater than equal to 0. So it may represent power spectrum. Now moving on to the last part of question 2. For function f of v is equal to 1 for when mod of a v is less than equal to alpha and 0 otherwise. So for 0 for mod v greater than alpha. So for this, the Fourier transform the formula, so we get as it is 2 sine alpha omega upon omega. So this is not non-negative. So as here it was so if it is an autocorrelation function for real WSS, the Fourier transformation is non-negative, and in this case it is not non-negative, so it cannot represent an autocorrelation function. So but if we put omega here, then f of omega, it is greater than equal to 0. So as f of omega is greater than equal to 0, it may represent a power spectrum. So in all these cases, all these two can represent an autocorrelation function. This cannot, and all can represent a power spectrum. Thank you.